kgs. And here's a way to remember this. K is, the prefix K is 10 to the power of 3, 10 to the power of 3 and 10 to the minus 3, that's 1. Okay, that gives you a gram. Okay. So this is 40. Okay. So that's a megagram. Oh, that's what. So B, I'll do one more. 320 teragrams. Tera is 10 to the 12. All right. And so that's 9. And then we'll take 2 more of these. So 3.2 into 10 to the 11 kgs. Okay. So this problem says soccer fields vary in size. A large soccer field is 115 meters long and 85 meters wide. What is the area in square feet? So area is length times width. And they want you to find, so they want you to convert this into square feet. And they say, assume 1 meter is that. Okay, so again, you want to cancel the meters, so the appropriate factor of unity you want is 3.281 feet divided by meter. Am I done? You have a meter square, so what you want is to square this. Okay. Now this is a meter square, which will cancel with that, and then you get a feet square. Okay. So okay. So tectonic plates are large segments of the Earth's crust that move slowly. So you see there are the plates. So those are the major plates. And do you guys know what is the radius of the Earth? It's about 4,000 miles. 6,400 kilometers. Okay. And the plates are about 40 miles thick. Okay. So the top 1%, and these guys are broken up into the plates. Okay. And this layer underneath is, this thing is plastic, sort of liquidy. So, and there's heat rising from the center of the earth. So you can think of it as pieces of wood floating on honey, and they're constantly in motion. Yeah. And these guys move about 4 centimeters a year. That is the rate at which your nails grow. So if you let your nail grow for a year, well, so a plate will move about that far in a year. Yeah. So the question is, what distance does it move in 1 second at this speed? Yeah, so it's actually, I'll just calculate part B, which sort of is a little okay, you can do part A later. What is the speed in kilometers per million years? Okay, so 4 centimeters per year. We want to convert this to kilometers per million years. Okay, so 4 centimeter is the prefix C is 10 to the minus 2. So 10 to the minus 2 meters, and 1 meter is 10 to the minus 3 kilometers. Okay, again, this kills that guy, that is 1, and 10 to the minus 2 came from the centi prefix. This guy is that C. You guys understanding this? Okay. Okay, now we want to convert this to a million years. So what is this prefix? 10 to the 6. You only had a year, so you put this in by hand, so you got to kill that. So that's 10 minus 6. A year is a millionth of a mega year. Okay? So there you have your number. Okay? So now this is 10 to the 5, 10 to the minus 6, that comes to the top, that becomes 40 kilometers in a million years. So a plate will move from here to Palm Coast in a million years. What's that? Yeah. Right. All right. Well, does this make sense? So let's see. Okay, so remember the plate tectonic theory, it's about 100 years old. South America and Africa, they were together at one time. Okay, so if the distance is, let's say, I don't know the distance accurately, but over 4,000 kilometers. So if 40 kilometers, so 4,000 kilometers, they move 40 kilometers in a million years. So it took them about 100 million years to separate, which is roughly right. Yeah. So you have an accurate number. Okay, I mean, you have a ballpark number for that. So this is very interesting. Yeah. So a plate will move 40 million years every, 40 kilometers every million years. Yeah. So here the average distance between the Earth and the Sun is that. Calculate the average speed of the Earth in its orbit. in meters per second, in miles per hour. Okay. I'll actually calculate in kilometers per second. Okay, because that number comes out where you can remember it. Um, so what we are doing is, so here's the sun, here's the earth going around, okay, and this is the speed we are calculating. Anybody know the speed? Oh, much faster than that. It's 30 kilometers a second. Okay, so the earth is going around the sun at 30 kilometers a second. So it's going from here to Palm Coast in a second. And that's the number we'll calculate. All right, so they give you this radius. And so how long does it take for the earth to go around? I'm sorry? 1 year. Okay, so the speed is distance traveled divided by the time. Okay, 2 pi r divided by, I guess, and 1 year is 365 days. Each day is 24 hours. Each hour is 3,600 seconds. So that's how many seconds there are in a year. Now, here's a little something that I encourage you to learn. Okay, so what you want to do is you want to take care of powers of 10 in your head rather than typing it in the calculator. Okay, so what we'll do is we'll make this 3.65 times 10 to the 2, 10 to the 2.4 times 1, so that's 10 to the 3, and then another 3, so 10 to the 6. Okay, and 10 to the 11 minus 6 is 10 to the 5, and then this would be 2 pi 1.5 divided by 3.65 times 2.4 times 3.6 meters per second. Okay. All right, so let's calculate that number. And then we'll borrow 2 of these powers, so make it 29.9 into 10 to the 3 meters per second. And of course, 10 to the power of 3 meters is a kilometer. Okay, so this is equal to 29.9 kilometers per second. Okay. So speed of the Earth around this, the orbital speed of the Earth is 30 kilometers a second. And of course, you can convert this to miles easily. 30 kilometers is roughly, well, it's about, so divide that by 1.6, okay, so roughly 18 miles a second. So now we'll do dimensional analysis, determine whether each of these following equations is dimensionally consistent. Okay, so what that means is on this equation, you have apples on the left-hand side and apples on the right-hand side. Okay, so let's see. Okay, so I'll do 1. v square equal to 2as. Okay. Now, here's how you write the dimensions. When you want to write the dimensions of a quantity, you put square brackets around it, and that indicates the dimension of that quantity. So the dimension of S is length. Okay. So is the dimension of v squared, is that equal to the dimension of AS? Okay. This is dimensionless quantity. Okay. Velocity is length square. Velocity is length over time. So dimension of velocity square is length square over time square. Is this equal to this? The dimension of acceleration is length over time square. Dimension of S is length. Okay. So this is dimensionally correct. Okay. So now that you found this, is this equation correct? This equation cannot be correct. Okay. Dimensionally, this guy is correct. So this one is not. Okay. So again, when you're doing dimensional analysis, all you're making sure is apples on the left-hand side, apples on the right-hand side. This equation, it turns out, is correct. But if that was a 5, for instance, or any other number besides 2, that equation wouldn't be correct. All right, here's a Fermi calculation, and which is pretty interesting. Okay. So, assuming the human body is primarily made of water, estimate the number of molecules in it. Okay. So we get to estimate the number of water molecules in your body. Yep. All right, so now you need to know some of your mass. What's your mass in kilograms? It's about 100 kgs. It's about 60, roughly 60 kgs, but we'll, because I'm not very good at math, we'll keep all round figures, okay? 100 kgs. And in this mass, we want to find how many moles of water there are. Okay, so it's 18 grams per mole. Okay, so we'll say roughly 20 grams per mole. So this tells you how many moles of water there are in your body. Okay, this comes to the top. We'll cancel some of this. Okay, and how many molecules per mole? Avogadro's number, that's 6 times 10 to the 23. I guess 6 times 10 to the 23. Molecules, well, just per mole. Okay, so that cancels, and so now this is, okay, again, like I said, this is a Fermi calculation, and you should be able to do this in your head quickly. All right, that's 100, 10 to the 3 grams, 20 grams into 6 times 10 to the 23. Okay. 3, that is 3 times 4, 7, 27. So that's how many water molecules there are in your body. Very interesting. Again, a very quick, rough calculation. How accurate is this number? It's within a factor of 10. Okay? So it's roughly accurate. Okay? Everybody good? Okay, so the average density of the sun is of the order of 10 to the 3 kgs per meter cube. What is the sun made of? What is the sun made of? 92% is hydrogen. And look at this. This is the density of water. So it's a gas ball, and the gravity is so strong. Well, I mean, the density, average density is that. Near the center, the density is more like the density of lead, of a metal. So the average density of the sun is that. Estimate the diameter of the sun. Okay. Mass divided. So we are, you know, so what we're really doing is finding the radius of the sun. And again, I'm going to use a calculator, but you know, you should be able to estimate this. I guess so. The mass of the sun is, as we saw a little while ago, it's that 4 pi by 3. The density is 10 to the 3 kg. Okay, the kg will cancel, the meter cube comes to the top, and 1/3 of that is a meter. Okay, so this is meter, that's 10 to the 27. 1/3 to the power of that is 10 to the 9. Okay, and so you have 6 divided by 4 pi to the power 1/3 of that. So that's the radius. Okay, and we'll make this, we'll borrow 3 from there, make that a kilometer, so 1,000,000 kilometers. Okay. And then let's find that number. The radius of the sun is 0.78 million kilometers, about 800,000 kilometers. Okay. All right. All right, so let's do part B as well. It's sort of interesting. Yeah. So what they say is, given that the sun subtends an angle of about half a degree in the sky, estimate the distance from the earth. Okay, so they're saying that this is half a degree, and they're asking you to find this distance. Or we'll call it, we'll call it Earth-Sun distance. Okay, we just found this diameter. Okay, what is d? Is twice the radius. Okay, so we just found that. Okay. And that's 1.56 Now, you guys know that theta is equal to d, the arc length, divided by the radius. So the Earth-Sun distance is the arc length divided by theta. Except that in that formula, what units does the angle have to be in? In degree? No, in radians. So you guys remember this formula? Okay, so this has to be, where there's the arc length, the radius, this has to be in radians. So this angle has to be in radians. So we'll have to convert that, okay? So the Earth-Sun distance is diameter divided by that. The diameter was 1.56 into 10 to the power of 6 kilometers, and 0.5 degrees, it's pi radians divided by 180 degrees. So, okay. So that's the conversion. So this becomes so the Earth-Sun distance is 180 million kilometers. Okay, so it's closer to 160 million kilometers, 150 million kilometers. But we are off because we use the average density of 1,000 kg per meter cube, which was not accurate. Okay. By the way, so the angle that the sun subtends at Earth is half a degree. Do you guys know what is the angle the moon subtends on the Earth? So, very good. How does he know that? Solar eclipse. Okay, so we are lucky. The moon and the sun are at such a distance that we can have total solar eclipses. Okay, so if you lived on any other planet in our solar system, you couldn't see a total solar eclipse. Jupiter with all its moons, 80 moons or so, you wouldn't see a total solar eclipse from the surface of Jupiter.